I got 30 minutes on this camera. I should be able to get this done. Alright, anyway, a hospital day has made a video about pi mostly, and then he did some stuff about how the universe works. But let's see if I can get to that universe stuff. He's talking a timing cycle basically, and that things are, which I like. You know, I like the timing cycle kind of model, but I don't really like what he's done with it, which is basically imply that there's an update period, you know, like a true timing cycle, and that somehow things could escape the updates, and that would account for the differences in composition of things because they age less, because they have velocity, and velocity would make them so they could, you know, it'd be at different points in time relative to each other, and I'm not sure that's correct. Yeah, I mean, it doesn't intuitively doesn't do much for me in terms of how they would skip this timing cycle, and I think the timing cycle still has to be explained. So I mean, I think you still have to go back to something more rudimentary to find your timing cycle. So I would argue that the timing cycle, as it's, you know, it's just here as a you know, a digital wave represented. You know, you can see the domino kind of look to it right there. So I mean, if all you have to do is say is these things tumble, you know, and there you have the origins of the fundamental reality. So I did see a Feynman video where he actually does say he believes the universe does do something like this. This reductive gets simpler at its core, and yet the real problem is just our perception, just because there is so much of it, you know, that we can't see the mechanism, because it is just so distant from us by its minuteness and the grotesque volume of it, and the volume of interactions that are below our perception are just so massive that we aren't seeing them. He speaks of this also when he talks about light, because he breaks it down to do these basic three elements of what most of what's going on around us is. Most of what's going on around us is photons, you know, intersecting with electrons, and then electrons emitting new photons, and that this interaction between electrons and photons is the substance of the universe. He didn't say that explicitly, so I don't want to put words in his mouth, but he said it pretty darn close to that's what he said. So anyway, it's a fair interpretation, I think. So what I would, you know, this was just one segment of this video. Most of the video was about pi, so that's, you know, I don't know whether two subjects exactly were mixed, because I don't think they're related explicitly. So I just get through the pi stuff here. So we'll just move along in this image to where there is a circle and a radius. So pi is just basically you're taking this thing, squaring it to find the circumference of the circle. So I will re-represent the drawing with a circle and a radius. So the interesting thing that, you know, I got from Feynman was, you know, in using his vectors, or his amplitudes, I think he calls them. Well, anyway, is this idea that squaring just means you square, you know, vector, and it just kind of doesn't make it visually easy to see. And so pi would just be saying there's three of these squares, which is just the number of the cubic representations of whatever your units are. So it doesn't matter what the units are. And you're counting the squared units in each of these squares, and to represent the circumference of the circle. And so you can sort of just see from the pattern that's formed is that 1, 2, 3 is easy. And it's this, you know, you obviously have these extra bits on each one to fill this other bit. But you have the 3 idea. It becomes kind of obvious how relevant 3 is to, I mean, how obviously relevant in terms of if you had a rule that says you couldn't go over in terms of even doing the area of a circle, you could see that 3 would be your maximum number because you have these extra bits to fill in this bit, so you'd end up over if you did 4. So you know your number is a 3 point something, even in terms of the relationship between a squared circle versus a circle. So even if you were doing area, you'd see that relationship. And obviously the relationship for circumference, you can just see how it is a, it's not the hypotenuse, it's a longer number than the hypotenuse of the square of the radius. But it doesn't, don't want to get too lost in all that. But my argument would be is that it really depends on how you're, this number pi is just an arbitrary relationship, so it doesn't have to be an explicit relationship. You're just basically saying there's at least 3 of these things related to the circumference of a circle because of a obvious relationship, and then for each circle there's going to be a different one for x, 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 x. So for each circle there's going to be a different one of these extra numbers going this way. Now we're back to this Feynman issue of the fact that this circle is made up of so many zillions of actual units. So I mean, our arbitrary big giant units don't mean much, but the fact is this thing is made out of very discrete units, and this number would have to represent the places of those discrete units, and it can't do that. So that's why it's just a continuous number, because it would have to represent all the units before it could resolve to a final number. So if you took a string and measured the circumference, as a length, and then measured your radius as a length, you could come up with explicit numbers, and you could say that's what pi was, because you measured it physically, and that's the relationship for this particular size circle. And you could get a finite number, but that finite number would be a representation of the fact that you did physical measurements that you can't do to the actual size of the circle. So again, you're going to be rounding it off. You'll be cutting it off based on how fine your string is and how accurate your actual measurements were. And so looking at his circle, just as a representation on this screen is made up of squares. So even though this circle looks like a circle, it's not a circle. It's actually got a little jagged square outline going all around it. A leasing, I think they call this in computer talk. But anyway, these are really very jagged lines because everything's made out of squares here. So there is no capacity to have a round thing. Everything has a geometry, sides to it. Wow, that's not very good. So the point is everything would be attached to a square, and the square is what's going to decide the sides of the square are what is really defining the circle. So even if it looks round, it's really squares. And my argument would be that its explicit shape is really just a bunch of triangles. And through triangles, you could figure out the actual distance of the actual circumference, because it's going to be a circumference based on a bunch of vectors or amplitudes, and that's the actual circumference. And pi would still be a relevant number, but the real geometry can be done based on just taking these angles and doing sines and cosines and all that kind of crap to find out the distance of the elements of the circle, and then just multiplying the elements times how many divisions you made for the number of straight pieces. So you could come up with explicit math that would be the actual circle versus the circle of perception, which is on a scale that is a million zillion times the wrong frame rate, the wrong frame size. So it's just the fact that we can't see reality, that reality looks like there's such a thing as a circle, but in actual reality there may be no such thing as a circle. Yeah, I think it's looking that way, that I'm declaring circles a non-existent thing. They don't really exist in nature. There's no such thing as a real circle. Yeah, that's sort of an interesting declaration to make. But anyway, that's what I'm saying. So what else did I want to do? So I did a little bit of his time theory. So yeah, so my theory would be more like there is my hypothesis, whatever. That there really is a domino kind of universe where quanta move at the speed of light and they don't do anything else, and they are merely trapped in relationships that look like circles. Okay, but they're not. But yeah, they spin, connected to each other, and are bound in relationship to each other. And I might argue that orbits are more like this kind of configuration than the standard model. And these quanta are in fact, if moving in one direction linearly, quanta, this would be called what we call a photon. And when trapped in some other relationship, I've sort of suggested a spiral of two photons, strings anyway, that this would be what an electron would be. And that these two objects, electrons being more massive by high orders of size. So there's a lot of photons inside of an electron, and electrons get into bound orbits to create what we call atoms. So, so you have the components of matter in atoms, electrons, and photons photons make up electrons. Electrons emit photons, and they absorb photons. So they're doing what I'll get into the next video, which is deciding this relationship between photons and electrons is what is accounting for what is called quantum mechanics. So quantum mechanics is merely a description of the relationship between photons and electrons substantially. And then the electrons form and may be bound by photons in some way. There's probably interactions between photons and electrons, but I don't know that. I mean, tying them together, that might have something to do with their release, but I'm not going to come up with a physical model at this point describing how photons become part of an electron or how the electron emits the new photon. But anyway, so this is essentially the energy cycle for most of matter, most of what we call matter. Anyway, so that's probably enough of a video so far, and then I will make another light video about the layers of glass, which seems to create a better display of the wave phenomenon described in like the two-slit experiment. Light, monochromatic light traveling through glass, sheets of glass of different thickness, creates the same sort of all the way on, double on, all the way off kind of pattern that you get with the two-slit experiment. So the same kind of, it appears as if the photons are reading each other's minds to decide how they end up kind of effect. And that was a great place to put that. Is represented in how light reflects off of glass. How much light comes back to me from the room, and how much light reflects off the glass back into the universe, kind of thing, with each transition between the material. And again, thickness of the glass, the distance between the two boundary layers having an effect on how much light is reflected off the surface, which creates a paradox or a quandary or something in need of resolution in terms of any kind of physical model explaining how that happens. So I guess we'll get there in the next video. Thank you very much. I think there was probably something else I wanted to say about pi. I thought of it last night, but I just it seems like there should be something else in there, but yeah, no. I mean, it's a what the real math should be cubic algebra and geometry, and they should just stay away from. I mean, if you want explicit numbers, the idea that the circumference is some sort of straight line, linear curve. There is no such thing, perhaps, in nature. Yeah. Anyway, enough. Till next time.